Hello, everybody, and welcome to my talk about sharing distributed content across a suite of Umbraco websites with a centralized taxonomy. Talk about a tongue twister of that title of this talk. I'll go into details shortly, so bear with me on the long title. First, a few words about me. My name is Mikkel Keller. I'm the head of development at Novicell UK. A long-time passionate Umbraco advocate, and I've been in love with Umbraco since 2007. So we have a long history together. Me and Umbraco, I've implemented a lot of websites over the years. Today, I'm going to talk about one particular project that involves a lot of Umbraco websites in a single project. So let's start with the beginning. We were approached by our client, the Institution of Engineering and Technology. They had a large portfolio of websites, and they had a strong desire to get more value from existing content distributed among those websites. And in particular, they had the desire to create mixed listings of content. So blog posts, articles, videos, job postings, you name it, from multiple different locations into a single listing with faceted filtering on top. So bringing in content from many locations into a single location and reusing the content to group it by topics, etc., and link it to other articles. So let me break down that long title for you. So sharing distributed content, it's all about breathing new life into existing content, and it's especially about capitalizing on an existing investment and reusing that valuable content that you already produced that's lying around in a huge organization. And we're doing this across a suite of Umbraco websites. So that means that we are aggregating that content from that full portfolio, so enabling any of the websites to use the full potential, all the content that is available throughout all the websites. And we're going to do that by introducing a taxonomy and a search service that enables centralized tagging, searching, and filtering of all of that distributed content. So this is basically about federated search, faceted search, and taxonomies. And there's a couple of technical terms here. So just to make sure that everybody is on board with what we're talking about, I'm going to break them down just in a little detail. So federated search is especially a technique that is used to search multiple data sources at once. So with a federated search, we can retrieve information from many locations with a single query and a single search interface. And this is relevant when we want to bring all of that juicy content into a single location. When we speak about faceted search, we know this, all of us know this from shopping on the internet when we see a product listing and we are narrowing down our product search. So it's a technique that allows users to exactly narrow down the result sets by applying filters based on facets, classifications. And classifications, that leads me to the next keyword, which is the taxonomy. So the taxonomy is basically just a well-defined, predefined classification of things, organizing them into groups or types. And we know taxonomy or tagging from the internet, from blog posts, there's a lot of that going on as well. So in this instance, we're going to use it with the content. So this project was a lockdown baby, which constituted an interesting start. So all the collaboration on getting all the information together was done online. We had discovery sessions and workshops using Miro. So there was requirement gathering and there was master data integration workshops. So the master data and integration workshops were particularly important for this project because we wanted to understand or needed to understand what data was distributed and how to centralize that and how to integrate everything. And there was even cookies, even though we were not together. Enough about that, moving on. Instead of going the very technical approach, I'm going to show you the editor experience that we were enabling with this faceted search implementation first, and then I'll go into the technical implementation afterwards. So the IET manages a large suite of websites. A large part of them is built on Umbraco 7. All Umbraco sites are built and maintained from a common CMS toolkit and pattern library. So there's a common design system, that's the pattern library, and there's a common base implementation of Umbraco. That gave us a perfect outset to mix this new functionality into the complete suite of websites. So we could actually do that by extending the CMS toolkit. We could make tagging functionality and editor-enabled tools available in all current and future IoT websites out of the box. So let's have a look. From the editor perspective, the functionality is based on one content block to rule them all. This content block can display that aggregated distributed content in several different layout styles and styles on the website. But basically we start by using a grid component, and that means that this can be mixed with other content. So you can still have a complete narrative and complete topic going on, starting with a hero banner with a nice statement and then an article, for instance, and then a list of these related content elements scattered all over the different websites. So there's a grid editor for this grid component of this content block that enables the editor to specify the query of content. And this content is aggregated automatically from the centralized search service. So you can do a pre-saved query. That means that the query is already known when the listing is requested in the website on the front end side. There's ability to restrict the content by source, so saying, I want to aggregate content from all of these websites, but not this particular website. I do not want to include. And then there's, of course, inclusive and exclusive tag queries that we use to refine the result set. It's possible to limit the result set and also to pre-sort the result set. And then there's a couple of display settings that enables us to use pagination or a fixed amount of results, displaying a content type tag, and then include faceted filtering. So this is important because this component can actually be used to just show 3 featured elements in a content block across on the website. This is done by limiting the result set, saying I only want the 3 latest published items in the centralized search service to be present, and this will bring up just a tile of 3 elements. We can extend on that, say we want a non-fixed result and we want pagination or infinite loading. And we can even extend on that and say, let's enable faceted filtering on top of this result set. This faceted filtering takes its outset in the taxonomy, the well-defined and predefined taxonomy, where all top-level tags automatically gets turned into facets. And then there's a hierarchy below. If we look at the tagging part, that's a composition on all document types. So by using this toolkit, all documents in all Umbraco websites have this very simple composition enabled, where they can apply tags and we can exclude any document from being exported. It has instant suggests. You cannot create tags, you can only apply tags. So there's no taxonomy management here. This is important because there's a lot of editors and we need governance to make sure that the taxonomy is clean and there's no duplicate tags, etc. And then there's a possibility to use global tags or global taxonomy that is for all the different sources, or local taxonomies that is only for the local source. Then, of course, we need a place to manage the full taxonomy. So there's a management area for managing the taxonomies. You can create, we can update, we can delete tags in hierarchies of 4 levels. We can join and move tags. And then, as I said before, all top level tags will equal facets. And then in order for maintenance, it's possible to import and export all the tags to update and make sure that it's clean and there's no duplicates. The system will, of course, show similar tags when you create a tag. So that means that you have the option of saying, okay, this tag is similar to what I'm trying to create. Let me use that instead. And it'll also, of course, disallow duplicate tags. Something to consider when managing a taxonomy. So there's a challenge here. When you're moving, joining, and deleting tags, it's very difficult to keep distributed content updated. This was one of the major challenges with a simple solution, but it takes an idea at least. So the solution here was of course to keep the taxonomy and the relation between the content and the tags in the central search service. So no tags are stored in the local Umbraco instances, and no relations between the content and the tags are stored in the local Umbraco instances. All of this is kept in the central search service. This means that when we join two tags, the central search service can actually update content from multiple different locations and readjust the tags, so it's only one tag going forward. When we view the document in Umbraco, all the applied tags are fetched through an API, so it's real-time, up-to-date with what's in the central service. There's also the ability to manage the index, so a complete and full re-index of a complete site can be performed decentralized. So from each individual Umbraco that's part of this federated search, it's possible to re-index all the content from any of those sites. This is important because if we introduce a complete new website into this subsystem as a subsystem, then it's important that we can initially index all the content. That was the user editor experience and how we put together the back office experience. So now let me talk a little bit about how the solution architecture looks. So we need a central search service to hold all of this information. It needs to be importing content from any Umbraco site or system based on applied tags. So that means that we can include any external source. It needs to be able to hold that central taxonomy management. It needs to be able to tag content, and it needs to be able to search content for the displays that I just showed you. So we created a standalone central service with an import API. So importing content from Umbraco was done fairly easily. Whenever a new piece of content was published, we'll look at the tags that were applied, and then we will export it from Umbraco and import it into the search and tagging service. So this is how we get Umbraco content into the centralized service. And any Umbraco website that gets connected to this central service will just supply the data to the service. We can also include other systems that Umbraco through the import API. Then, of course, we need a search engine, so we connect the search engine as well. I'll talk a little bit about the details of the search engine at the end. And then, of course, we need the management API. So the central taxonomy management and governance interface is hosted separate from any of the other websites. That means that they can control who are allowed to perform updates on the taxonomy, and they can limit that to a restricted amount of editors. But it doesn't matter because it doesn't have to be in the individual Umbraco websites. So that's a strong point here. So the taxonomy management is done again through an API. Nothing is kept in the Umbraco instance. And then lastly, when we set up a content block, we also use the management API to set up the content block and create a pre-saved query. We tag the content, and then ultimately there's a search API that enables us to bring the listings into the front end. So we can render the front end based on the search request and the response from the search API. So that's the standalone central service, 4 different APIs with different restrictions on top. So the public APIs are hosted separately from the private API. So the import API, the search provider, and the management APIs is a private standalone runtime, whereas the search API is an open, accessible API. And that makes for a strong security on top of everything. So the tech stack, let me talk a little bit about the tech stack. It's something old, it's something new. So as I said initially in the speak, the suite of Umbraco websites are based on Umbraco 7. So that's existing websites, and they were all based on the same CMS toolkit. So the basic functionality of putting together different pages with different content elements were already present. Currently, we mostly work with Umbraco 8 and Umbraco 9 fast approaching. So again, it's important here to loosely couple the search service to the actual Umbraco implementation. And this was done in order to be able to upgrade at a later point to a newer version of Umbraco as well. And that's why the APIs that I showed you before is very, very important, because they kind of isolate the front end, the interface in the back office from the actual functionality. So when it becomes time to update, it's basically just redoing the user interface with the new SDK from Umbraco 8 or potentially Umbraco 9 very, very soon. So the loose coupling is very important. Then the search engine is an Elasticsearch. It's the de facto standard for fast, efficient, and scalable search implementations today. It has a lot of functionalities that is important for this implementation to be scalable. Mostly it has built-in support for faceted search. We keep all the tags in the taxonomy in Elasticsearch as well. So it's very efficient to do tag suggests when applying tags or when filtering a query based on tags. We can search very, very efficient within Elasticsearch. All the content from all the different sources gets transformed into small tile objects. We call them tile objects because they represented the tiles on the end listing. In order to have enough information for the tiles, we require a published date, a title, an image, a small short text, and with that data that can come from anywhere. So we even allow developers to go in and specify how one specific document type translates into this tile structure. And all of this data from all the multiple different sources, this small piece that represents each piece of content will be indexed into the same index in Elasticsearch, which makes for the federated search part and makes it very, very efficient to search multiple locations in one go. The central search service was a standalone service, or is implemented as a standalone service, and that means that it has no ties whatsoever to Umbraco. So we are free to make any technical choice we want. So the obvious choice was to implement the service as a .NET 5 Web API project. Again, ensuring longevity and return on investment on the long lifetime. So separating from Umbraco makes this reusable with other external systems as well. And then lastly, everything is hosted on Azure using DevOps for continuous integration and deployment with serverless hosting. So that means that the public API is hosted in an app service by itself. The private API, import API, management APIs is hosted in an app service by itself as well. So let's have a look at the search API and the search models. So if you remember the view I showed you previously, I'm just gonna rewind a little bit. So here's the display settings, for instance. In order to display this result set, we need data for the filtering, we need data for the actual result set, and we need data for the pagination. And because we have these different styles of showing the result set, we also need display settings. So let me show you how that looks. So if we fast forward again. So the search API is very simple. from the outside. There's only one endpoint. It's a tagging service. We search by a token. The token represents a pre-saved query. So we don't have to pass all the tags and all of those because those have been pre-saved at publish time when we publish the content block. And that means that we do not have to send them back and forth. The only thing that we need to do is the filters afterwards. So the first part is, of course, the result set. And here you'll also see the tile structure. So any piece of content in any subsystem will be transformed into this small tile object. Then we have the pagination data and we have the filters as well. So the filters are important because those are actually based on the result set. So the initial query set up by the editor defines automatically what facets are available. So the implementation has to be dynamic to understand what facets it can use. So that means we're not showing the complete taxonomy in a specific listing. We are only showing the facets that are available within that result set. And then once we're applying filters to get to subsets of that result set, we will narrow down the result set, but we'll keep all the filters available so you can go back to the initial result set as well. Within the filters, you have the possible values, you have the control, it's checkbox, for instance, and then you also have the counts of results within each of the different options, which is again important because we want to show, we want to be able to do the faceted filtering and show how many results you get by clicking specific facets. And then on to the display settings. So the display settings are also important because we can visualize the result set in many different ways as described. So by storing the information the editor puts in to the content block on the central server, we can give back the full display settings object that tells the front end how to render that particular content element. So in this instance, we can see that we use pagination. It's the default theme, the page size is 12, etc. All of these informations gets sent to the front end. The first initial load in the front end is done server side. So that means that this display settings object is not necessarily exposed to the dynamic part of the filtering. It's only used on the first rendering. So this is more or less how we created faceted search based on multiple sublocations and a centralized taxonomy. That was more or less what I had for you today. I thought half an hour was a very short amount of time, and normally I speak too much. So I have gone and shortened it just a little bit too much for today. And since this is not really a live session, I cannot ask for questions and have you help me spend all the time talking about this interesting project. But on behalf of the team, thank you for listening and thank you for having me.